What's our universe made from? What elements comprise the planets out there circling the sun? Or our rocky planet that we call home? What's the composition of the incredible mass of our mountain belts or the endless ocean basins? Well, my answer to that is not much. Mostly, everything is made up of very few things. And it is for this reason I put it to you that we need to occasionally reconsider one of the foundations of chemistry, the periodic table. Let's try to view our elements by their abundance, not by their atomic attributes. When we do this, we get a very different view of chemistry. Let's shift our viewpoint. This is ASU. What's the first thing that comes to mind when you think about a science classroom? For me, it is a periodic table adorning the wall, a collection of symbols containing one or two letters enclosed in small boxes that are arranged perfectly in rows and columns. The periodic table tells us a lot of useful information that can help us to better understand the world that we live in and ourselves. And although you may feel overwhelmed by the numerous little boxes that make up the table, it turns out that you only need to know just a fraction of it to understand something quite fundamental, not only in the context of the Earth, but of the universe. Each little box on the periodic table is dedicated to a particular element. An element is a substance that is made up of atoms only of that element. For example, the element oxygen, denoted with the symbol O, consists only of oxygen atoms. The element hydrogen, denoted with the symbol H, consists only of hydrogen atoms. The same principle applies to every other element found on the periodic table. An atom, as you probably already know, is made up of three different subatomic particles: protons, neutrons, and electrons. The protons and neutrons combined make up the core, the nucleus of an atom. And the electrons are found outside of the nucleus in the orbitals. The mass of an electron is incredibly small, so an atom's mass is essentially equivalent to the mass of its nucleus. If you look at the periodic table, you can generally find the atomic mass for each element listed with significant figures. And if you examine the table in its entirety, you will see that the lighter elements are basically found in the upper rows of the periodic table, and the heavier elements are found below. It turns out that the heavier elements are formed when nuclei of lighter elements fuse together at extreme temperatures and pressures inside stars. This means that it takes longer to form the heavier elements. If a particular element takes longer to form, what do you think it means for its abundance in the universe? That's right. The heaviest of the elements are much less abundant in the universe. That means they're less abundant on Earth and less abundant in our bodies, in you and me. Let's go to our periodic table. Let me highlight the 20 most abundant elements in the human body for you. Now, I'm going to circle the 24 most abundant elements in the universe. There is a major overlap, isn't there? Let's finish our thought. If heavier elements are in general less abundant, that would mean the lightest of elements should be enormously abundant. And it turns out hydrogen, the lightest element on the periodic table, is the most abundant element in the universe. While we can't make a direct correlation to each element's atomic mass to abundancy every time like we did with hydrogen, and that's because there are other factors in addition to atomic mass that we need to account for, thinking about the periodic table this way helps us to utilize the information it provides to better think about the world that we live in. So the next time you find yourself staring out into space at far-off stars, galaxies, and planets, give yourself time to think through the chemistry. Everything out there, like everything here, including you, is made of a very few things. The basic atomic building blocks are super abundant. Everything else is pretty much a rarity. And an atom of iron or oxygen on Mars or a neighboring galaxy is exactly the same as you would find here on Earth. The periodic table possibly does a poor job of representing this incredible distribution of elements, so it is even more important you don't forget it. This was ASU. Thanks for watching.